Statement that we have here is to reverse an array using the two-pointer technique. Let's understand this better with the instance that we have here. The input is going to be 1, 2, 3, 4, 5, array of integers having these numbers. And the output when you reverse this array is going to be something that looks like this, 5, 4, 3, 2, 1. So obviously when you reverse an array, the last element appears at the first position and so forth, right? So the first element will be at the last position. That's what a reversal of an array is called. So when you reverse an array, the resultant output has to look something like this. And we're supposed to solve this problem using the two-pointer technique. So the problem statement is pretty clear. We understood what are we supposed to be doing. That is only reversal of an array. Now the question is, how do we solve this problem? How do we code this problem? And what is this two-pointer technique? So this is one of the algorithm that we kind of use to solve majority of the problems. We'll understand this algorithm in the couple of slides that we see in future. But this is going to be the problem statement. Now let's look at how do we solve this. And what is the two-pointer technique? Now the two-pointer technique is nothing but we've got two pointers, okay, that you can name it I, J, or you can also name it as left and right, okay. But always in the two pointers algorithm, you're going to have two pointers, left and right. So one can start at index 0 and the other one can start at index n-1. That is the first position, the last position. But when you talk about two pointers, not necessarily that always the pointers will start one at the beginning and one at the end. So they can be one after the other also. But we will see all the alternatives of two pointers as to where you place the pointers in future problems as well. But here when we talk about two pointers in simple terms, we will have two pointers that we will make use of. Now one approach here that you can think about, or you know, that kind of hits your mind directly is, suppose if you have an array of elements 1, 2 and 3, and all that you have to do is reverse it. So that the resultant output would be 3, 2, 1. So you might think of a solution where you create a new array, right? And then you start reading the array backwards. So you will say I is equal to n-1, array of length, array dot length -1. So 3 will become at the first position, and 2 will be here, and 1 will be here. But this also is an acceptable approach. But the thing is, time complexity remains big O of 1, but time complexity remains as big O of n, but space complexity will also be big O of n, because we need an additional array that we create, right? It is no longer big O of 1 like we've seen in the previous problems that we've solved. So this is one approach that you can follow. But the thing is, this you're not making use of any two-pointer algorithm here. That is, instead what you're doing, you're just creating a new array and you're shoving the elements, you're reading or traversing the existing array from backwards, and then you're reading all the elements one by one and shoving it into the new created array. This is an acceptable approach. But the thing is, your space complexity is big O of n. But how do you solve it where keeping the time complexity as big O of n, but space complexity as big O of 1? For that, we make use of this two pointers algorithm. Now in two pointers algorithm, it's very simple. We will always have two pointers. Now you have to decide the position of these pointers depending on how you solve the problem or what requirement do we have in the problem. All right. So now if you see here, we have an array 1, 2, 3. Let me add some more elements, 4 and 5. Imagine this is the array. Now the resultant output has to be 5, 4, 3, 2, 1. Okay, the opposite of it. When you talk about two pointers, like mentioned, we will have two pointers, left and right. For ease, I will consider one pointer at position 0, I, and the other pointer at position, the last position, that is j, n-1. N is total number of integers that you have in the array. So I and j. Now what are we doing here? We keep swapping array of I and array of j. So now we have this I and we have this j. Array of I and array of j, we swap. So what happens? 5 will appear here and 1 appears at 5th position. Okay, this is how we expect it to be, right? When we reverse also, the last element has to appear at the first position. So that's how we're proceeding with. So we are likely close to the solution. And what do? We do I plus plus. Okay, and we do j minus minus. We decrement j and we increment I. Now what we do, we again swap array of I, array of j. So 4 comes here and 2 shifts to this position. And what are we doing again? We're doing I plus plus j minus minus. Okay, so we keep changing or incrementing I and decrementing j until when? Until you reach a point where your I value is no longer less than j. If you see here it was 0 and this was 0, 1, 2, 3, 4, 4. So 0 was less than 4, of course. Then when it came here, it was 1 and this was 3. 1 is less than 3, yes. But when you see here, it is at the same position. So you can stop the pointer, swapping of the elements and incrementation and decrementation of I and j of the pointers unless you reach a stage where your left is no longer less than your right. Okay, in other terms, it has crossed each other. So this will become I now and this will be j. So in such a case, you'll have to stop because you've already performed the required operation, that is reversal of an array. So you already have 5, 4, 3, 2, 1. That is the expected output that we were expecting or anticipating. So simple. So this is how the two pointers technique is going to work. One instance of two pointers technique we've seen in this problem, but there are certain other alternatives. I mean, certain other tweaks that you can make in two pointers as to with respect to the position of the pointers. We will keep looking at the two pointer technique later in our future problems that we solve as well. Okay, so but this is how the algorithm is going to work. We have two pointers always, and you decide on where you put I and where you put j and how you move them accordingly. So in this case, without I and j, I don't think so we could have solved this problem. But we need I and j, right? Because we have to keep switching them, keep moving them, keep making a shift. And that's when we can land to the resultant output. So this is how two pointer is going to work, and we just did a dry run solution. So let me just quickly revise again. So we have left pointer which starts at index 0. We have right pointer which starts at index n minus 1. And what are we doing each time? We're swapping the elements. Left and right we're swapping. And we keep moving left plus plus. We keep moving right backwards, right minus minus. And until when are we doing it? We will repeat it until this condition is satisfied. That is, left is less than right. The moment left becomes greater than right or left becomes equal to right, we immediately stop that operation and we come out of the while loop. That is when we've got our expected anticipated output. So we no longer have to execute any instructions. Okay, so we've understood the dry run approach. Let us code the problem and understand better. Okay. All right, so let's code the problem. So we've understood the solution, we've understood the algorithm, we've also done a dry run. Now the same thing that we understood, we're going to implement it via coding. Okay, so we have this class solution and public void reverse string. So here we have reverse string. String is also a collection of characters. So we have an array of char. Okay, so what are we doing? First thing, we're solving this using two pointers technique. So we will make use of two pointers. Int left, that is at index 0, int right, and this will be n minus 1. So how do we get n? S dot length minus 1. Okay, so S is the array name here. So we have declared and initialized our two pointers. Now what do? We have to keep moving the two pointers, right? And until when should we move the two pointers? Until the condition left has to always be less than right. The moment left is no longer lesser than right, which means we have deduced the expected output and we no longer need to perform any set of execution of any set of instructions. All right. So we have left, we have right. Now what are we doing? We're doing swapping. And how do we swap? Let us declare another variable in temp that is going to be 0. Okay. So how do we swap? I think we are familiar with the process of swapping, right? So we first save the element that is s of left in the variable temp. And what do? S of left is now going to be S of right. And what is going to be S of right? Temp. Okay. We store the value of S of left in temp so that we don't misuse it. I mean, we don't miss it, right? That is temp. Okay, this is how we swap. And after every swap, what do? We do left plus plus and we do right minus minus. Simple. Okay, so there's nothing that we have to return. The return type is void, so we can leave it as such because the array itself becomes the opposite. So now the same array you can use. So let's revisit the code again. So we have declared 2 pointers, left is 0, right is length minus 1. So we make use of the stem because we need an extra variable when we swap the elements, right? And until when are we going to swap the elements? Until this condition is satisfied. So the left pointer is lesser than the right pointer. And this is how we do the swapping. We always save the s of left in a temp variable because when you do s of left equals s of right, the value that you already have in s of left will be overridden by s of right, right? That is why we first store it in a temp variable so that even if it overwrites, we have a backup. Okay, so temp is s of left is s of right, and s of right becomes temp. That is swapping of the two elements. And we do left plus plus because we have to move I, and we do right minus minus because we have to move the j. Okay. Okay, so let's run this. I'm so sorry. Int has to not be temp, it has to be char. Okay. Because we have array of characters. Okay, let me run this now. Okay, so we have two cases here and we are able to run these two cases. Now let us run the test cases, I mean the edge cases. So even if you have edge cases, this solution should suffice that. It has to stand tall. Okay, so we had 477 cases and all the 477 cases have been cleared. Can I expand it? Okay, so this is how we do it. So this is the memory that it makes use of, and the time complexity will always be big O of n here, and the space complexity is big O of 1. So this is how we do reversing an array using the two-pointer technique. So one thing you have to be very clear about is two-pointer is an algorithm that you use or apply in majority of the problems. Okay, even in future, the most of the problems that we're going to aim at, we will make use of this algorithm again and again so that you'll understand the tweaks that we have in two pointers as to how do we decide the positions for the pointers. So in maybe in the future videos, not necessarily the left pointer starts from 0 or the right pointer starts, at the end. Maybe it can be one after the other as well. Okay, so those kind of tweaks and those kind of modifications we will see in the upcoming videos. This brings us to the end of the video. If you found something knowledgeable, then do like, share, and subscribe to stay tuned, and we shall see you on the next video of DSA.